Swayam Prabha. Digital India. Educated India.
Welcome to the lecture of statistical modeling. In this lecture, we are going to look at descriptive statistics. So, as a part of this lecture, we are going to see some of the numerical and graphical methods to describe our data. So, we are going to look at the central tendency measures, the dispersion measures, cross tables, and some of the graphical plots. So, let us look at the problem statement that we have. So, a cab driver is driving for 2 months in the months of Jan and Feb through routes A and B and has collected the daily travel time to reach a destination. Now, in our data, route A is mapped as 0 and route B is mapped as 1. So, the file that you have been given is called traveltime.csv and it is a comma separated value file. So, let us see how to read the file in R using the function read.csv. So, read.csv reads the file in a table format and creates the data frame. So, the input that the function requires is basically the file and row.names. So, if you want to get rid of the index, then you give row.names equal to 1 and file is nothing but the name of the file that you have. So, let us see how to load the data. So, I am going to use the function read.csv and within single quotes I am going to give the name of the file which is traveltime.csv and now I want to get rid of the index. So, I am going to give row.names equal to 1 and I am going to save this as a data frame time. So, once you run this function you have a data frame where all the data is stored. So, now after reading, let us see how to check the structure of the data. So, I am going to use the function str which will display the internal structure of the data. Now, in our case the input is basically a data frame, but apart from that in general you can give any other object as well. So, if you want to check the structure of a data frame, you give str followed by the name of the data frame and once you run the function the following output is displayed which tells me that time is a data frame with 40 observations and 3 variables. So, the variables are travel time, route chosen and month, and travel time is basically a numerical variable and route chosen is integer because it is mapped as 0 and 1 and month is basically a factor with 2 levels Feb and Jan. So, here you can see the months have been ordered alphabetically with Feb being the first level and Jan being the second. So, if you want to check the structure of a variable, you give the str function where within brackets you give the name of the data frame followed by a dollar symbol and then the name of the variable. In this case travel time is what I want to check. So, I am giving time dollar travel time which tells me it is a numerical variable and you also have the first few values being displayed. So, now I know my route chosen is an integer, but actually it should be a factor. So, let us see how to convert route chosen as a factor. So, we are going to use the function as.factor to convert the variable route chosen to a factor. So, here I am saying time dollar route chosen is nothing but as dot factor of time dollar route chosen. So, what this means is I want to save the changes that I have made to the variable. So, I am going to make the changes such that it gets overwritten and here I am using the function as dot factor because I want to coerce it to a new data type and I am going to give the variable name. So, once you execute this, let us recheck the structure again. So, now you can see your root chosen has become a factor with two levels, which is 0 and 1, 0 being root A and 1 being root B. So, moving further, let us see how to check the summary of the data. Now, summary is the function and it gives you the summaries of various model fitting functions. The input is an object, but in our case the input is actually a data frame. So, let us see what does the summary give you. So, it gives you the mean and the 5 number summary for a numerical variable and the mode or counts for a categorical variable. So, by 5 number summary I mean the minimum, first quantile, the median, the third quantile and the maximum. So, these are the 5 number summary that it gives you for a numerical variable, and for the categorical variable it gives you the counts or the mode. So, again instead of a data frame you can also give a single variable for which you want to get the summary. So, let us see how to do that. So, if you have a numerical variable, so you just give summary of time $travel time. So, this gives you the 5 number summary and the mean. So, all of it gets displayed. So, for a categorical variable there are two methods. One is you either give summary followed by the categorical variable, in our case I am giving month. So, you can see the frequencies of each categories are displayed. Otherwise, you can also use another function called table that gives you the same output. So, table is another function that you can use to get the counts of a categorical variable. Now, apart from this, individual functions can also be used instead of a summary. So, I am using the function minimum to get the minimum value from travel time, which is nothing but 10.31. So, the other individual functions are maximum, mean, median and quantile. So, summary gives you everything at once, but these individual functions give you only the specific values. So, while the summary gives you only central tendency measures, it does not display dispersion measures. So, by dispersion measures I mean the variance and standard deviation. So, variance is calculated as follows. So, VAR is the function name and you give the variable name as an input. So, in this case travel time is the input for which I want to calculate the variance. So, the next dispersion measure is standard deviation represented as SD in R, and you again give the variable name inside brackets and it gives you the standard deviation. So, let us see how to get the quantiles for a numerical variable. So, quantile is the function and inside the bracket I give the numerical variable name. So, in our case travel time is the numerical variable for which I want to get the quantiles. So, by default it gives you values in steps of 25. So, you can see it is 0%, 25%, 50%, 75% and 100%. So, if you recall, this is the first quartile, this is the second, this is the third. So, the second quantile is nothing but the median, which has a value 19.24. So, how will you interpret these values? It means that 25% of the data has travel time which is less than or equal to 16.46. That is how you interpret the result. Now, instead of quantiles, which is the default values that you get, you can also get deciles. So, by deciles I mean in percentages of 10. So, it starts from 0, then goes to 10, 20 up till 100. So, under the parameter props you say 0:10, which is nothing but in steps of 1. So, I have 10 numbers from 0 to 10 and then I am just dividing it by 10 to get the proportion. So, I have 0%, 10%, 20% till 100%. So, this is how you get quantiles and deciles in R using the function quantile. So, now let us look at cross tables and contingency tables. So, cross tables are nothing but two-way tables which summarize your data. So, large amounts of data can be restructured and summarized using the cross tables. So, we have already used this function before where we get the frequencies or counts of a categorical variable. Now, in this case we are going to use the function to get a two-way table. So, let us see how to get that. So, table is the function like I again said. So, you give your two categorical variables here. In our case, month is one of the categorical variable and root chosen is another. So, whatever variable goes before the comma is basically the row values, and whatever goes after the comma is basically the column values. So, in this case you can see you have a two-way table where month is the row and root chosen is the column. So, let us see how to interpret this table. So, wherever I have month as Feb and root chosen is 0, which is nothing but A, I have 10 observations like that, and wherever I have month chosen as Jan and root is still A, I have 10 observations here. So, this is how you interpret your table. Now, this is making the entire procedure really hard for us because there is no description as such in the table. So, let us just add a small description to this table by giving month and root under the parameter D and N. So, you give C, which is a concatenation operator, and within brackets you give month and root, month being the row and root being the column. So, now you know your row stands for month and your column stands for roots. So, this is how you get the description added to a table. Now, this table gives you only frequencies or rather counts. So, let us see how to convert these count to a proportion. So, prop dot table is the function that we are going to use. So, you use prop dot table, and whatever function you used earlier to calculate the counts, you give that as your input. So, earlier we used table and we gave month and root chosen. So, that becomes my input to prop dot table. So, now you can see all your counts are converted to proportions. Because all of these counts were equal, you are getting equal proportions for all the 4 cells. So, till now we have looked at numerical measures that describe your data. We also saw how cross tables help us in describing data in terms of frequencies and proportions. So, now let us look at some of the graphical methods that help us in describing our data really well. So, to begin with, we are going to start with histogram. So, histograms are quantitative plots where you have quantities in the x axis and the corresponding frequencies in the y axis. So, hist is the command in R. The input is basically the numerical variable, in our case it is travel time. Now, instead of just generating a blunt plot, I am just adding a small description. So, now main is nothing but the title of the plot, which reads as histogram of travel time, and x lab is nothing but the x label. So, the label for the x axis, and y lab is nothing but the y label, which is the label for the y axis. So, x label is nothing but travel time and y label is the count. So, on to my right you have the histogram that gets generated once you run the command. So, you can see x axis has travel time and y has the corresponding counts. So, let us add some description to the histogram. So, I am going to make the histogram more granular and more colorful. So, let us see how to do that. So, this is in continuation to the previous code. So, after y lab equal to count, you just give us comma and continue with the same code. So, I am giving a breaks of 20 and color is equal to red. So, breaks is equal to 20 will give you more bins in your histogram, and color equal to red will color all the columns in your histogram. So, you have the corresponding output here. So, compared to the previous histogram, you can see there are more bins here and all the columns have been colored red. I again have travel time on x axis and the counts on the y axis. So, now let us see, instead of counts can we have proportion on the y axis. So, I am going to now change counts to proportion. So, again this is also in continuation to the previous code. So, after color just give a comma and continue. So, I am setting frequency is equal to false, which will basically convert the y axis to proportions. So, here you can see your y axis has been converted to proportion and I have changed the y label correspondingly. So, this is how you convert your counts to proportion. So, you can add more granularity if you want or change the color in histogram. So, I am going to add a density curve on this plot. So, inside the lines function you give density function and the input is basically the variable for which the histogram is generated. So, once you execute this command you will see a density curve is plotted on top of the histogram. Now, ideally if you have more data the curve looks really smooth, but because we do not have a lot of data it is not very smooth in this case. So, the next graphical measure is the box plot. So, a box plot is a visual representation of the statistical 5 number summary. So, like I earlier said, the 5 number summary is nothing but minimum, the first quartile, the second quartile or the median, the third quartile and the maximum. So, lines extend vertically from a box plot and these lines are called whiskers. Now, they indicate the variability outside the upper and the lower quartiles. So, any data point which is outside these whiskers are treated as extreme points and are represented by a small point. So, let us see how to generate a box plot in R. So, box plot is the function and I am giving travel time as my input. Again main is nothing but a title for your plot and y label is the y label for the x axis. I am setting the limits of the y axis between 9 and 30. So, let us see how does the plot look. So, on my right you have the plot that gets generated once the command is run. So, you will see a box and a thick band inside the box. So, the lower end of the box is the first quartile, the thick band is the second quartile which is nothing but the median and the upper end of the box is nothing but the third quartile. So, you have whiskers that extend from the box on either side. So, you can see these whiskers are drawn at minimum and maximum. So, our minimum value is 10.3 which is where the lower whisker is and our maximum value is 28.67 which is where the upper whisker is. So, the lower quartile is at 16.5, the median at 19.25 and the third quartile at 22.4. So, we know our whiskers are at minimum and maximum. So, that is entirely based upon how normally distributed your data is. So, if your data is perfectly symmetrical, your whiskers are at minimum and maximum, which is in our case. We know the median and mean are really close. So, we know it is pretty much a very good normally distributed data. So, whenever you have a skewed distribution, the whiskers are drawn differently. So, we will see in some time how to draw the whiskers for a skewed distribution. But before we move on to that, let us see how to generate a box plot which is broken down by categories. So, again box plot is my function. So, I want a travel time separately for each of the month which is Jan and Feb. So, everything else remains the same apart from this. So, on my right I have the box plot where the x axis is nothing but the month and the y axis is again the travel time. Just that in this case the x axis is broken as Feb and Jan, the 2 months, and I have the corresponding box plots for each. So, this is how you get multiple box plots for different categories. So, in our case we have only 2, but if you have more than 2 categories you can also get a box plot for them. So, now let us see how does a box plot look for a skewed distribution. So, for this I am going to generate a set of 1000 random numbers from a population which has a mean of 1.67 and a standard deviation of 3. Now, we have already seen how to generate random numbers from a normal distribution. So, once you generate the numbers, if you look at the summary, you know the median is at 1.54 and the mean is at 1.64 roughly. So, this is the 5 number summary along with the mean that you get. So, you know the distribution is slightly skewed, but not very skewed. So, again I am going to have a box plot function for this. So, on my right I have the plot. So, you will see there is a point below the lower whisker and there are a couple of points above the upper whisker. So, in this case the whiskers are drawn at 1.5 times the interquartile range. So, the interquartile range is nothing but Q3 minus Q1, which is the third quartile minus the first quartile, the difference between them. So, the lower whisker is basically drawn at Q1 minus 1.5 times the interquartile range and the upper whisker is drawn at Q3 plus 1.5 times the interquartile range. This is something you do not have to do. The function box plot automatically does this. So, it basically checks if the variable that you have given is normally distributed or not. If not, it does this automatically. So, in this case x is not normally distributed, it is slightly skewed on one side. So, the function box plot automatically calculates the whisker as 1.5 times the IQR, which is the interquartile range, and it plots the box plot. So, all points above and below the whiskers are basically extreme points, which basically have a tendency to sway your distribution from normalcy. So, your box plot can basically control by how many times the interquartile range can vary. So, that is governed by a parameter called range inside the box plot. You can look up the help menu, and where the default value is given as 1.5, that can be changed to 2 or whatever you want based on your data. So, just to quickly summarize, in this lecture we saw how to structure and summarize our data. We also looked at some of the core descriptive functions, which are nothing but the minimum, maximum, mean, median, mode and quantile. We also saw how to generate a cross table by frequency and proportion, and we also looked at histogram and box plots, which are the graphical measures to describe your data.